Welcome to my channel, A Woman in Physics, and in particular, welcome to the first exercise in this new exercise series. In this video, we will tackle the problem of kinematics of point masses. And with this, let's have a look at the problem. At what initial speed does a car driver travel when it takes 32 meters from the time of detection of an obstacle to a full stop after emergency braking, if the reaction time is 0.9 seconds and the braking deceleration of the car is a equals minus 6.8 meters per second squared? How long does the total process take? Now, how can we solve this problem as efficient as possible? First of all, what are the given values and what are the values we're searching for? The given values from this text is, on one hand, the total distance, s equals 32 meters, the first time period in which we need time to react, which is 0.9 seconds, and we know that the negative acceleration in the second regime, where we finally get our car to stop, is a equals minus 6.8 meters per second squared. And we realize from the text that we are searching for the initial velocity, v0, and the total time, t. So let's make a short scheme. We can see here that initially we're driving here on the left-hand side with a speed of v0, which is unknown. And for a certain time, t1, we need time to react. Our brain and our body needs time for us to realize there is an obstacle and to hit the brake. This is the time t1. After this time, we are still traveling at v0. However, we know that after we have decelerated our car and come to a full stop, the final velocity will be 0 meters per second. And we know the total distance for this whole process is given as 32 meters s. So, how do we solve the problem in detail? Well, I already said that we have a first regime and a second regime. And we know that in this first regime, or in this first section, we have a uniform motion. A uniform motion is always associated with one basic equation of motion, which tells us that the distance we are traveling is a direct function of the time, and in particular s, in this case here s1, equals v0 multiplied by t1. Of course, v0 is what we are looking for and t1 is given, but we do not have the distance s1. But we know that after this first section there is a second section, which is associated with an evenly accelerated motion. And for an evenly accelerated motion, we have another equation of motion which associates the distance we're traveling with the time. And in this case, we know that the distance s, in this case s2, equals a divided by 2 multiplied with t2 squared plus initial speed v0 multiplied with t2. In addition, of course, for an evenly accelerated motion, we do have a second equation of motion which relates our velocity to the time. And in particular, the equation looks like this: velocity equals a times t2 plus v0. Now, we do have three separate equations, but when we have a closer look, we can realize that in our particular case, we know that the final velocity will be 0 meters per second. And the final velocity is, of course, the velocity that we reach after the second section has been completed, and in this case we can associate it with the time t2 that we need for this second section. So we have an easy equation that relates our acceleration that is given and our velocity v0 that we are looking for with the time t2 that we need for the second section. So now we still have three separate equations, but of course they are not separate at all. We know that basically we do have a combined motion, and we know the total distance s is a combination of s1 plus s2. And since this is pretty easy, we can put both equations into one, which is given here. So we know that s equals v0 t1 plus a divided by 2 t2 squared plus v0 t2. Now, this is quite nice having this one relation because we know that the total distance had been given. And we know we are looking for v0. In addition, also a and t1 are given, but t2 is still unknown, so we cannot put all our data just inside this equation. We still need t2. But we've just seen that there is an equation which relates again t2 to a and v0. So we can use this equation, just put t2 on the left-hand side and the initial speed and the acceleration on the right-hand side of the equation. And we can take this equation and put it into the above equation for the total distance. And what we get is a nice equation where only known variables or our one unknown variable, v0, that we are looking for, are inside. But it still looks a bit chaotic writing it this way, so we can simplify it by taking the last two terms and putting them together. And by this we get this very easy looking equation and we can solve it, right? We are looking for v0, but we realize v0 is inside both terms on the right hand side, and one is a linear and the other one is a quadratic term. So we have to solve this, and the question is how. And maybe you're not that familiar with mathematics, are you? If you are, you should realize how we can solve it. If not, let's just say it's like solving a quadratic equation. A simple quadratic equation, if we put s on the right-hand side of the equation, you can see that I have transformed it in such a way that the quadratic term does not have any variable, and we can solve this. And from mathematics, as I said, we know that there is an easy solution to quadratic equations. And the solution for such an easy term like 0 equals x squared plus px plus q is given here. Of course, every quadratic equation has two solutions. Now, we of course know that we are looking for one initial speed and not for two, and it cannot have two values. So where's the problem? If we look closer, we realize that there is a negative sign right in front of the square root. So the two solutions come from this plus minus in front of the square root. And if we think about it, minus, taking it into account, would imply we are getting a negative value. And in our particular case, the negative sign doesn't have any physical meaning because we would get a velocity smaller than 0 as a result. And of course, this doesn't make any sense. So let's take this idea from mathematics and just apply it to us solving our problem. And if we do this, we see that we get an equation which is with one solution, v0 equals a multiplied with t1 plus the square root of a squared t1 squared minus 2as. And now we can just take our given values and put them into this equation. And if we go back to the slide where I've shown the given values, we realize that all of these three values are given in their basic units. And I'm a huge fan of using basic units. And usually when a variable isn't given in the basic unit, I'm trying to convert it right at the start, right on this slide, because later you do not have to think about it any longer. If you know you can rely on yourself to have transformed any unit into a basic unit initially, then now we can just take the values and put them into, yes, precisely this equation. And we can just put it into a calculator and we get that the initial speed was 15.6 meters per second. So congratulations, we just solved our problem, right? And this is precisely where I love going back again to the slide that I've just been showing you. And this is why I love putting down the variables we are searching for. And it makes it a lot easier to compare it at this point. Going back, having a look, yes, we were looking for the initial speed, but wait, we were also looking for the total time. So we are not done yet. But calculating the total time isn't that complicated, right? It's the same approach. The total time is a combination of the time for the initial regime where we need still time to react, and T1, the reaction time, is given, so it's trivial. On the other hand, we have to use also T2, the time for this second regime, the second section. But this isn't really complicated because we already do have an equation for the time. And we know that T2 equals minus V0 divided by A. So we can take this and the given T1 and put it all into this one equation. And what we get is that the total time is simply 3.2 seconds. One last look at our values we were searching for confirms that yes, that was all we were looking for. So we are done with this rather easy task. So I hope you didn't have any problem with this exercise, but if you did, just let me know in the comments below, and please let me also know if you want an additional exercise regarding this particular topic in physics. Of course, over the time I will upload further videos regarding different fields, from thermodynamics to optics, and we will see where we are going. So please check in, and if it's really been helpful, maybe you could recommend others my videos, and I would be very happy if you would consider subscribing, and please give me a thumbs up if you liked it. And I hope to see you soon for one of my other videos. Bye!